next student decided to remix his experience and do a student-defined project. So his hard work paid off, and we were all tapping our toes by the end. So please welcome Charlie.
Hi, my name is Charlie. I'm going to be a rising junior next year at High School. And for my project, I built a drum sequencer. I'll run you through a demo, and then I'll go into how everything works. So use this arcade button to play a sound. And then it plays it back, and you can add on to it. So now it's playing 2. And if you don't like one of the sounds, say like, I don't like this clap, I can clear it. Now it's just the kick and the cowbell, and I could add something else in. Then there's a fill, so I can go through all of them, just add on. Just do some crazy stuff. And then if I want to, I can reset it and just turn everything off. So this is my second year at BlueStamp. For my first year, I built an autonomous plant watering system. And I really learned a lot about hardware and firmware through that experience. And this year, I kind of wanted to challenge myself a little more. So I decided to design my own project, in a student-defined project. And I based it off of this guy in London named Look Mom No Computer, which is kind of problematic considering you need a computer to code. And that's actually where I ran into a lot of my problems. So I got the hardware designed the way I wanted, the aesthetics and all of that. And then I uploaded the code, it was open source, he wrote some of it. And I was kind of debugging it, getting some things to work, making my way through it, kind of understanding it. And after about a week or two, I realized that it just wasn't working at all, and I kind of had to start from the ground up. And so I did that, and surprisingly, I actually learned a lot more that way than I would have if it just worked on its own. So for example, I ran a bunch of test files. Using serial.print, I could visually see what my hardware was doing, and then I could bring it over and edit the code. I started with basic things, and then worked my way up to more complicated things like an interrupt, looper, all of those things, and like the clock in. So what this arcade button does is it starts at low, and because it's a momentary push button, when you click it, you can think of it visually like it's always at 0, the sequence is always at 0, but when you click the button, it goes to 1. So say you click it and it's at 1, and then if you click it again, depending on the in-between time period, it will go to 1 again, and it will just continue to repeat. The fill button, which just plays it over and over again, what it does is it's just telling this channel output to continuously be at high, so it's just 1, 1, 1, 1, 1, 1, over and over and over again. And there's a delete button, which is pretty self-explanatory. It just deletes one step. There's a clears the whole all the steps. A reset, which kind of restarts the whole program. There's 2 potentiometers, which are variable resistors, and one of them can affect how long your sequence is. There's another one that just shuffles up all the sounds. And then there's a channel select, which is just moving between the 6 different outputs. And then the last button that I didn't explain is the bank button. So there's 6 outputs, and each output can have a different sequence on it. So if you change the bank, there's a total of 12, and that's why the sequence array with a list is 12 by 42, because the 12 represents the different channels and the different sequences you can make, and the 42 represents the total amount of beats in that array. And so inside this box, there's an Arduino. That's where I did all the coding and the hardware and wiring, and that's controlling this box. And this box is just housing all the sound and samples. So there's a WAV trigger, which you upload an SD card, and then you can play different samples if you're choosing. And there's 16 different mono jacks on this one, and so you can just plug into whatever one you like. And so I really had a great experience with this project, and I kind of wanted to see if I could leverage it into a business, or not, maybe not a business, but sell it in the market. And so I compared this sequencer to other sequencers out there, and I realized that up there you can see there's a low-end sequencer, a mid-tier sequencer, and a high-end sequencer. So mine is in between the low-end and the mid-tier in terms of cost. It's around $150. And mine doesn't have as many features as some of the mid-tier sequencers and even the low-end sequencers. It's not as user-friendly, and it's not plug-and-play. So what I ended up thinking was, although it might not be a successful product on the market, that other people could benefit from my experience and how I had to work to solve all these problems and go through all the code and the way I commented it out. So I uploaded everything to GitHub, and there's a big movement of people who want to build their own stuff like modular synths or drum sequencers, and it's kind of just do it yourself. So I think other people, when they want to build something like this, it'll be really easy for them, and they can continue to modify and add on to what I've done. And I think BlueStamp as a whole has just been a really great experience. I really like to help people. I like to solve problems, and I think engineering is a great way to do that.
You have a metal case.
Yeah, so
We should elaborate on that.
yeah, I should have talked about that a little more. But so the metal case actually caused a lot of problems for me. And right now I have a temporary fix, which is, I don't know if you can see, but there's these nylon screws that I plugged in to avoid a ground issue. But if you play it, like, say I have that kick, and if I touch it, it just stops because there's current going through my hands to the box. So that's a problem that, I mean, there's a lot of funky stuff that goes on with audio, especially when you're dealing with metal and wiring. So if I could have done it over again, I would have mounted my PCB to this metal box, similar to what I've done this one, and it just makes it a lot cleaner and there's not as many issues.
How many different sounds does it play?
So there's 6 channels on here, but say you have like this kick, right? You can find which wire it is. This is really messy. But you can plug it in, so the kick stops because I unplugged it. You can plug it into this, and it plays a different sound. So there's 16 sounds on here, and you can, like, if you really wanted to, you could unplug the, you could unscrew everything, and so you can unplug everything, and you could load up different samples onto an SD card, plug it in. It's really up to you. Like, it depends, like, maybe what music.
It's unlimited.
Yeah, it's unlimited.
What's your DJ name?
Chuck the Duck. Yeah, I'm kind of inspired by my cousin in Houston. He's a DJ. This is kind of a cool project.